Hello, this is Scholar Strive doing some math. Today in geometry we'll be looking at inscribed angles and polygons in circles. So first off, let's do vocabulary. So we got a circle, and we have an angle whose vertex is on the edge or on the circle itself. Okay, this is what is known as an inscribed angle. An angle inscribed in a circle has its vertex on the circle, and the sides of an angle are chords. So if we call this ABC, we have angle ABC is an inscribed angle. AB would be a chord, and BC would be a chord. Okay, the measure of an inscribed angle. Oops. So let's call this ABC again. Is half of its intercepted arc. So if the arc of AC was, say, 60 degrees, then the measure of angle ABC would be half that. So this would be 30 degrees. So if the arc AC is 60 degrees, then the measure of the inscribed angle would be half that, which is 30 degrees. Intercepted arc is an arc that lies in the interior of an inscribed angle and has its endpoints at the intersection of the angle and its circle. It's basically the same picture. A, B, C. And we would say that this piece here is the intercepted arc, the red. Okay. If two angles intercept the same arc, then the angles are congruent. So let's see what that looks like. So we got a circle here. And let's say we have this angle. Okay, in black. And then let's say we have this angle. Okay, so notice how they both share this arc right here. If you compare the red and the black, they both share this arc. So if they both share the same arc, that means their angles are congruent. So that angle is congruent to that angle. If I use some letters here, let's do that. This A, B, C, D. We would say angle BAC is congruent to angle BDC. BAC is congruent to angle BDC. An inscribed polygon is a polygon in a circle where all its vertices lie on the circle. So that would be an inscribed pentagon. 1, 2, 3, 4, 5. 5 sides. So inscribed pentagon. Circumscribed is So circumscribe is basically kind of saying that the circle surrounds the polygon. It's basically saying that the polygon is inscribed in a circle. The circle circumscribes the polygon. An inscribed polygon is the same thing. If the measure of an inscribed angle is 90 degrees, then the intercept arc is 180 degrees. So let's draw a circle here. So if they say that this is 90 degrees, that means the arc. So if angle ABC is equal to 90 degrees, then arc AC then the measure of arc AC is 180 degrees. Also, the triangle formed will be a right triangle that is inscribed in the circle, and the hypotenuse will be the diameter of the circle. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay, so if we have a circle and we have some sort of quadrilateral, A, B, C, D, that means angle A plus angle C has to add up to 180 degrees. That's what it means to be supplementary. And angle B and angle D added together also have to be 180 degrees. Let's do some examples. Use circle P to find the measure of each of these things. So angle S. I should change the name of this. It should be angle RST. Angle RST. Okay, so we're looking at this angle here. Let's use a color. So we're looking at that one. So remember, this is an inscribed angle because the vertex S is on the circle. Okay, and it's equal to half its arc, so 30 degrees. Half of 60 is 30. Arc QS okay. So since 37 is half of whatever QS is, we just double 37, which is 74 degrees. RQ okay. How do we find RQ? Okay, we know that blue plus green is equal to 180 degrees. Why? Because the red line in the middle here is the diameter. Diameter splits the circle in half. So half of 360 is 180. So the blue, we figured out, well, that's what we're looking for. So blue is, we'll call X, plus QS, which we found out to be 74 degrees, equals 180. So x equals, or RQ is equal to 106. Find the measure of HJ, measure of angle HGJ. What did you notice about these two angles? Okay. So measure of arc HJ. Okay. So I'm going to draw this here, blue. Okay. And look at this angle here. Okay, that's an inscribed angle. So that means the arc HJ is equal to double 39. So that is 78 degrees. Okay, and then let's look for HGJ. HGJ. Okay, so because they have the same arc here, that means same intercepted arc, that means the measure of angle HGJ is the same as that 39. And what do you notice about HFJ and HGJ? They are the same. Example 3. Name two pairs of congruent angles in the figure. So two pairs. So one pair will be this one and this one, because they both share this arc here. So angle PSQ is congruent to angle QRP or PRQ. Okay, and then the other pair of angles are these ones, because they both intercept this same arc. So angle SPR is congruent to angle SQR. Find the indicated measures. Okay, checkpoint 1. Number 1, here we go. GHJ. So they're looking for this angle here. Okay, it's an inscribed angle. That's 100 degrees, so we know that's half that. So half of 100 is 50 degrees. Arc CD, okay, we know that it's double 40. So 80 degrees. Angle RTS. We're talking about this one here. Okay, so believe it or not, that 31 degrees is the same arc, because if you look here, there's that arc, be this piece. And if I draw the other angle, that's the same arc. So they are both the same angle, 31 degrees. Find the value of each variable. Okay, so we have a four-sided object, four-sided polygon inscribed in a circle. So that means opposite angles. So angle Q and angle S, x plus 88 is equal to 180. So x equals 92. Okay, and then y plus 100 is also equal to 180. So y equals 80, 80 degrees. Part B, same thing, opposite angles. So 3y plus 3y is equal to 180. So 6y is equal to 180, so y is 30. And 8x plus 4x equals 180. So 12x equals 180. So x equals 15. Okay, a right triangle is inscribed in a circle. Okay, so we have a circle and we have a right triangle inscribed. The radius of the circle is 5.5. What is the length of the hypotenuse of the triangle, right triangle? So because of the last, or I guess one of our theorems right here, let's find out which one. Yeah, this second to last one right here. X. Triangle form will be a right triangle that it's inscribed in the circle, and the hypotenuse will be the diameter of the circle. So because we know the radius, which is 5.5 centimeters, the length of the hypotenuse of the triangle is also the diameter. So 5.5 plus 5.5 is 11 centimeters. And that is our hypotenuse. Part B. So we know that opposite angles, so we have a quadrilateral inscribed in a circle. Because it's a quadrilateral, we know that opposite angles in that polygon, that quadrilateral, add up to 180. So 4b equals 84. Divide both sides by 84, and we'll get b is 21. And then we have 5a plus 90 degrees is 180. So 5a equals 90. So a equals 18. Hopefully this helped you out. Have a good day.